Hi, my name's Steve Mann and this is Paper Classroom. Welcome to another one of our science tutorials. In this tutorial we're going to be talking about ionic bonding. Now, just to remind you all, there are 4 types of bonding. There's ionic, there's covalent, there's hydrogen bonding. All those 3 are relevant for the paper industry, and so I will be producing tutorials on all 3. There's also metallic bonding, but I'm not going to bother about metallic bonding. So, what is ionic bonding? The clue is in the word ionic. It's to do with ions. So with ionic bonding, atoms produce ions. They produce anions and cations. And because the ions are oppositely charged, then they attract to each other. So what we're going to look at is how and why do they produce ions. If we start off, if this blue circle here represents a whole atom, that is the nucleus and the electrons, then we know that for every one proton with a positive charge, there must be one electron with a negative charge, and therefore atoms are always electrically neutral. So if we take one electron away from an atom, it's now got one more proton than it has electrons, because we've taken an electron away. So the charge on that ion, we call it an ion now if it's not balanced, the charge on that ion is +1. If we take 2 electrons for an atom away from an atom, then the charge on the atom is +2. And if we take 3 electrons away from an atom, the charge is +3. And it works the other way around as well. If we take an atom and we manage to push an electron into it, it's now got one more electron than it has protons, and therefore the charge on that ion will be -1. If we could give that atom 2 electrons, the charge will be -2. And if we could give it 3 electrons, the charge will be -3. Now, in previous videos, we've talked about the structure of an atom. We've talked about the nucleus, and we've talked about the shells, K, L, M, N, etc. Now, one thing that all atoms want is a full outer shell, and atoms will do whatever they can to achieve that aim, to achieve a full outer shell. Now, the classic example to demonstrate ionic bonding is that of sodium chloride. So what we're going to do is have a look at the sodium atom first of all, then we'll have a look at the chloride atom, and then we'll put the 2 things together and we'll see how ionic bonding works. So, did you remember the symbols for sodium and the symbol for chlorine? Here's a sodium atom. So the yellow in the middle, that's the nucleus, that's the protons and neutrons. And these lines here, these circles, represent the first 3 orbitals, or first 3 shells, K shell, L shell, M shell. Now, what about some facts about sodium? So, chemical symbol Na stands for the Greek word natrium. What do we know about sodium? We know that sodium has an atomic number of 11. Because it has an atomic number of 11, we know that it has 11 protons, because the atomic number is the number of protons in the atom. And because all atoms are electrically balanced, if it has 11 protons, then we know it also has 11 electrons. Now, how are these electrons distributed within the shells of the atom? Well, as we said in previous videos, in the first shell, it can only hold a maximum of 2 electrons. So there we have 2 electrons. That shell is now full. Nothing we can do can put any more electrons there. We've got 9 electrons left. So we've really got to start to fill up the second shell. Now the second shell can hold a maximum of 8 electrons. And if you count up, that's what we've got. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 electrons in the second shell, 2 electrons in the first shell. That's 10 electrons. We have 1 electron left. So there it goes. The atom has had to create a third shell just for that 1 electron. Now, as I said, every atom dreams of having a full shell. So for sodium to have a full shell, it's got 2 options. Either it can bring in 7 more electrons so that it has an outer shell, a full shell with 8 electrons, or it could simply get rid of this 1 electron. Now, what do you think is easiest, to acquire 7 or to just lose 1? That's right, it's much easier to lose 1 electron. Now that we've lost, there's just a reminder, the electron has a negative charge, so the electron zooms off with a charge of -1. We're left with this sodium atom now that's short of 1 electron, and I've just popped in there a little +1 to remind us we've now got 11 protons, 10 electrons. So that particular atom we no longer call an atom, we now call it an ion, and that sodium ion has a charge of +1. We'll have a look at chlorine now. Here's the chlorine atom. Here's the nucleus, where we have the protons and the neutrons. We're just looking at the first 3 orbitals again. And what do we know about chlorine? The chemical symbol is Cl. Its atomic number is 17. So because its atomic number is 17, that tells us it has 17 protons. And because it's electrically neutral, it must have 17 electrons. So we'll do like we did with sodium, we'll see where the electrons go. The first 2 electrons go in the first shell. That's now full. 15 electrons left to play with. In the second shell, we can fill it with a maximum of 8 electrons. 8 and 2 is now 10. We've still got 7 electrons left. So the 7 electrons go in the third shell. So what does that mean? Well, in order for chlorine to be happy, it has either got to get rid of 7 electrons or simply acquire 1 electron here. What do you think it's easiest? Is it easiest to shed 7, or do you think it's easier to acquire 1? It is easier to acquire 1. So chlorine would love to get an electron from somewhere. Okay, so we'll put these 2 atoms together now. So here we have the chlorine molecule, the chlorine atom. Here we have the sodium atom. This does not want that electron. This would love to have an electron. So guess what happens? That's right. The electron goes over. Now what have we got? We've now got a chlorine atom with a full outer shell, so that chlorine atom is really happy. It's got an extra electron, so it now has a charge of -1. The sodium atom is extremely happy. It now has a full outer shell, but it's one more proton than it has electrons, so that will have a charge of +1. And of course, the outer shell that has now completely disappeared, so this is a slightly smaller atom now than it was. So just to remind us, this ion now, the chloride ion, has a charge of -1, and this sodium ion has a charge of +1. So what we've effectively got now is a negative ion and a positive ion. And because like charges repel and opposite charges attract, one's positive, one's negative, and because they're opposites, they will attract. The ions will attract to each other, giving ionic bonding. And it's as simple as that. I hope you understood it. If you would like any more examples, let me know and I can prepare some more for you. Thank you very much for watching this video, and I hope you enjoyed it. Please give us any feedback, and we look forward to seeing you returning for more of our videos.